Uh, Hello? Can everyone hear me in the back? Okay, cool. Thanks everyone for coming. Hope you've been having a really good conference for the last few days. I think there were some really great stuff. Thank you very much for coming to hear me speak. I'm not sure if anyone's familiar with this, but there's a thing on Twitter that people do called Friday Hug, and I would like everyone to stand up really quickly and just put your arms out like this. Friday Hug. And I'll get a picture of this too. Yeah, come on, everyone. Yeah. Awesome, thank you. Friday Hugs. Spread the word. So my name is Grace. I'm a software engineer at Yammer. Yammer is a enterprise social network that was acquired by Microsoft several years ago. And I'm here, other than to give out Friday Hugs, I'm here to talk about herding cats. It's one of the hardest things that you can possibly do. I'm not sure if this phrase is familiar to many people, so I'll kind of give a little bit of a backstory about the phrase itself. I have a friend who used to tell me a story about when he was living with his roommate in university. He would play this game with his roommate's cats. He would take a laser pointer and try and get one of the cats into their bookcase by using the laser pointer. The cat would follow it into the bookcase. And while that cat was still in that bookcase, he would try and get the other one to go into the same bookcase with the same laser pointer. Obviously, it was very difficult, and that's kind of where I got the title from. So we're here to talk about cats, but this isn't a story about impossibilities. It's about being able to train teams and help them learn new tricks for dealing with on-call issues or any sort of production issues that might come across with your software as a service, web application, whatever you have. So let's rewind a little bit to the year 1 BC, or before cats. In the beginning, there was only darkness. But suddenly, out of this darkness, there came a sound. Please imagine pager noises. We tried sound checking this earlier, but I guess it doesn't work. So when I started at Yammer, we didn't really have this concept of being on call. I'd heard lots of stories about these fabled teams at other places where people had to carry pagers or mobile phones with them all the time, just in case something went wrong with the production environment. Okay, so actually we did kind of have on call at Yammer. And by that I mean one person who was on call all day and all night of every day of every week for the rest of his life. Sort of, anyways. Everybody was always around to help, of course, but eventually the team became so large and the entire environment was so unwieldy that it was really unreasonable to ask this one person to have to be responsible for everything. And we knew this deep down inside, just nobody wanted to be the first one to say it. But why not? Why didn't we want to help out this poor soul who had to have the entirety of Yammer on his shoulders? Well, we were pretty confident back then, and we kind of thought, more or less, and I paraphrase here very strongly, we don't need no stinking on-call rotation. Our product is so good, it doesn't need a whole team to keep it running. In a single word, this is bullshit. Eventually, as you would predict, disaster happened. So, it was a Friday night, though for some of us it was still under the Thursday category because we hadn't slept much. A massive production issue occurred for some reason or another. This is several years ago, so my memory is fuzzy on this. And there was a handful of either dedicated or insomniac engineers who were struggling to keep things from falling apart. Eventually, we had to call for help. And this is roughly how the call went. I had to make the call at 3 in the morning to that one poor engineer who was on call. Hi, sorry to be calling at this hour. I'm from Yammer. I work with engineer's name. Can I please speak with him? It was as awkward as it sounds. just for a little bit of context, I think this guy had just gotten back from his honeymoon or something, like it was only a week or two, and unfortunately his wife answered the phone, so it just made it that much worse. So finally he came online, very groggy, probably didn't even have time to get coffee or anything. But after several hours, finally we managed, with his help, to get our production environment back into a stable state. But it was at this point, roughly, we decided we can't keep doing this. This guy really needs to sleep. So the decree was made. We should have an on-call team. Hooray, problem solved, right? Like many things, it was much easier said than done. There were many things that we came across that were completely foreign to us. And the first thing was, how do we do maths? At the time, we decided to have just 4 engineers, or cats in this case, to be the guinea pigs, guinea cats, whatever you want to call them, to iron out the process. And out of these 4, one of them was the cat herder, or the tech lead. We had, at the time, 1 monolithic Rails application and about 15, give or take, services, mostly in Java, and obviously in 2 different stacks completely. And we tried our best to figure out how we can organize and split the responsibilities in such a way that it didn't make everybody's lives miserable. Well, it just ended with 4 really sad cats. This is an actual photo of a sheet that I wrote back in that time when we were trying to figure out our scheduling so that it didn't suck for everyone, but really all the options sucked. The next problem that we came across was all these acronyms. We had to start getting used to them, and they just kept on cropping up everywhere around us. We had no idea what most of them meant in the first place, and we couldn't avoid them. They just became bigger and bigger and bigger and bigger, and not the actual acronyms, obviously, mostly the intensity with which we had to address them. So I'll quickly go over the main ones that we care about, and I'll try to remember not to use the acronyms for the rest of the slides because otherwise it might get confusing. Mean time between MTBF, mean time between failures. This is basically the time, say there was an incident on production, how long is it until the next occurrence of an incident? MTTR, mean time to recovery, is a little bit related, but it's more of the how long does it take for you to be able to fix this issue once it occurs. Both of these are very important, and I'll go into that a little bit more in detail shortly. SLA, or service level agreement, this is kind of the agreement or contract that you're making with your users, promising them our service will be available to you for X number of minutes for the entire month. For us, it was, I think our internal goal is 99.975%. Externally, it's 99.9%. If you do the math, I think it roughly came out to about 99.9 is about 45 minutes a month. It's not a lot of time. So, and that was obviously another big thing that we had to deal with. AAR, after action review. This one I actually had to look up not too long ago when I was making these slides because I didn't even remember. It's a little bit of an older term that we don't use anymore, but it is a little bit, it's pretty self-descriptive. It's the write-up that you do after the incident takes place, just describing how you actually resolve the issues and the timeline and all that kind of stuff. IR is very similar. This is what we use nowadays, incident report. So this is pretty much exactly what the other thing is. It's 1 letter shorter, so we like it better. But this was a lot, and there was just so many things that we had to focus on, so we had to pick which ones that we actually needed to start with. So we started with the first 2. Mean time between failures versus mean time to recovery. Which one mattered most to us? It was hard to decide. It's kind of like deciding between how often your cat vomits on the rug versus how fast can you clean it up when it does. And obviously there were various things that we had to consider. The first one in gray being the rough business impact of each. So obviously mean time between failures means you'll hopefully have less frequent incidents. Mean time to recovery, if you have a very good mean time to recovery, usually means that you'll have faster recovery from those incidents. Again, cat, vomit, rug, cleanup. The blue was what we figured we roughly needed to achieve either of these goals. So mean time between failures obviously means that we would have to have much more stable systems than what we currently had, while mean time to recovery, we needed to have very good response training for all of our engineers who would have to be responsible for our systems. Both obviously have their benefits. Engineers being less interrupted less frequently for mean time between failures is obviously very good. It means that they can do their regular work and not be stressed out all the time. Mean time to recovery, in a way, it means that engineers can learn quite a lot about various different services, because they'll have to know how to handle anything that comes up for all of the different services that you have. Negatives of both of these, of course, exist as well. Mean time between failures, it's possible that it's more disastrous even though they're less frequent. It's kind of like you can have a big bang issue that happens and then you can go for months and months without anything happen, and then all of a sudden perfect storm happens and then it just completely shits the bed again in a few months. Mean time to recovery would not have this exact problem, but it is possible, if you think about it, that you would have more frequent issues. You're able to respond faster to them, probably because you're getting a little bit more practice with dealing with them. So there's always trade-offs. Neither of them are dependent on the other, but of course, according to this formula, and I swear this is the only formula that I have on my slides, both of them, the SLA, or service level agreement, sorry, depends on both of these. And it's not actually a scale of whether you can have one or the other on opposite ends. It's a range for both of them. So as one goes up, you don't have to go up in the other, and in fact, it could actually go down temporarily. Then when you're happy with where you get to fixing the first one, and it doesn't have to be 100% at this time, you can go ahead and start trying to push up the second one. Whatever you do, though, obviously, you need to stick to the important left-hand side of the equation, the availability, or also known as your uptime. And eventually, of course, you want to get to this thing. And of course, the last thing we had, one more thing that we had to deal with was how to do documentation. Unfortunately, all these incidents that happened had to be maintained. We had to keep track of them somehow, and AARs used to be the way. Now after action reviews used to be the way that we kept track of all the incidents that happened. Now we decided to go with incident reports instead. But getting engineers to write whole paragraphs of descriptive texts, possibly even customer-facing ones, cats, herds. So we had several options for how we were going to write our incident reports. The first one we started experimenting with was Google Doc forms. But the only tricky thing about this was that it was hard to read the reports. I'm not sure if you're familiar with it, and this may have changed, but at the time, Google Docs, when you submit a form, the result set that you get kind of just looks like a spreadsheet. So with long form text, it gets really difficult to kind of go through. The next option we had were Yammer notes. It's a rich text editing feature inside of the Yammer product. Obviously, we use the Yammer every day for communicating with each other, so it was kind of a no-brainer, but they're very hard to analyze. You can attach a note to a conversation that happens inside of Yammer, but then being able to search for them or finding a previous one was a lot more difficult, so this actually didn't work out too well. We also used Jira for our bug tracking, very powerful tool, obviously, and it wasn't perfect, but it sort of worked. It had the main things that we really cared about, and it had ability for querying, so you can search related issues that happened in the past. It's what we went with. So here's another real-life photo of how we were actually trying to figure out what to track in our JIRA tickets once we decided to go with it. And a lot of these details we actually thought at the beginning were very important to keep track of, but as we went along, some of them naturally kind of stopped being filled out by people, so they've since become optional, really. However, the key things are there still to this day, including obviously summary, start time, end time, which services were impacted, how many users were impacted, any relevant tickets that might have come up for follow-up afterwards. So all this was being done over the course of several months, and we thought, hey, we're really starting to get the hang of this. Maybe. Actually not. The way at the time that we did projects, it made it such that when we created new services in our microservice architecture, we kind of ended up dumping them into the pool with everything else once it was finished. And this meant basically that the number of services grew faster than the engineers who had to maintain them. And of course, more technologies means more toys for the cats to play with. For example, we had at this time about 4 different data stores that we added on top of all the services that we have. Imagine, going back to the cat analogy, imagine taking a bunch of yarn balls, throwing them on the ground, and then letting your cats loose on them. It's chaos, really. Even so, we still tried to rotate our engineers through different projects to try and prevent expertise from forming, kind of the silos that some people refer to them as. And it's a good idea. You want your cats to be able to play nicely and exchange their yarn balls with each other, but not every cat will be able to play with every single ball of yarn, or even know that other ones exist for that matter. So unfortunately, despite our best efforts, there were some silos that kind of came up out of the way that we managed our services and projects. And a massive side effect of this was that you got really no clarity over who's responsible for what. And after the cats are done playing, they all just saunter off and let someone else deal with the mess. And of course, last but not least, the most important thing that we had to care about was burnout. It is a real thing. When you put people in charge of something, there's that imminent stress of having to possibly have to respond at any given point of the day, night, weekends, during the daytime as well. We didn't want this to happen with any of our engineers, and we didn't really have a good solution at the time, but it was something that we had to keep working to minimize. So several months of this passed. Initially, all these efforts had been part of an experimental process for staffing projects that we had dubbed the initiatives model. The first iteration of this ended, so did the first attempt at building our fixed on-call team. That was the 4 cats, one tech lead, and all the different services that we had. And we finally decided, okay, I think we're ready to roll out the process to all the rest of the team, or so we thought. Obviously, there were plenty of adjustments and much needed ones that we still had to make. So the first thing that we tackled after this next phase of the process was to split our responsibilities by stack. If you remember, I mentioned that we had at the time a Rails monolith and a number of Java services. This was the easiest boundary to draw, so we did that. We had a Rails on-call team and we had a Java on-call team. Kind of made sense at the time. We also added our London office. So Yammer is based originally in San Francisco, but now we have a London office and a office in Redmond, close to Seattle as well. By adding the London office, obviously, it meant that all the people in Pacific time could actually sleep at night. It was amazing. However, of course, it also meant that with more people, they all had to gain knowledge in different areas that they were probably very unfamiliar with. And it's a lot to have to digest when you're first coming on call, basically. So we had to make sure that we trained everybody and had them both be open to helping anybody in an area that they are more familiar with, while also obviously being open to ask anybody else who would be more knowledgeable in a different area that they're less familiar with. This honestly was the hardest part. Remember the Park the Cat story? It's kind of like that. One cat will go in, but then the other one will leave, and it's a mess trying to coordinate everyone. But it is still possible to get the entire team on board, and in the end, that is what you kind of need. You just have to be very persuasive, and I'll touch on this a little bit later as well. Lastly, this is good for any part of life as well, practice. We did drills, we did tabletop exercises, we did breakdowns of some of the common issues that we'd seen. We just did a lot of practice to make sure that everyone was able to respond without any help, hopefully, and hopefully they wouldn't have to do this at 3 in the morning anymore. So now that we had everyone on board with this, we had to also deal with some actual technical stuff. So the first thing that we also decided to consolidate was to have all of our alerts in a single configuration repo. This made it easier because by having them in source control, we had a history of any changes that were made to the alerts, but also it was much easier to maintain. You didn't have to go through any UIs or anything, and we also made sure, and if for some crazy reason the system blew up and you lost all of your configured alerts, you had a very easy way to bring them all back at once. And while the engineers were busy doing their things, we figured they might not always have time to do all the documentation and the pesky incident reports and all those things. And managers weren't doing anything, so make them incident managers. The role of the incident managers was to make sure that all the necessary engineers were coordinating with each other on any issues that came up. But most importantly, they did the external communications with the teams that had to tell the customers basically the terrible news that our service was not available to them. Just like how your cat probably doesn't want to hang out with someone, even if that they don't like, you could try forcing it, but it's not going to do it. It's kind of like that with engineers and talking to customers, I'm sure, especially when it's about something that they've accidentally broken. Besides, engineers will be busy fixing those problems anyway, so this saves them quite a lot of time. Lastly, we also started to add runbooks to everything. It makes it much easier to follow, even if you don't know about any one of the services in depth, so this is very important. We also had a unified runbook, so each service would have its runbook, but we also had a single unified runbook that was much easier to search through, and you didn't have to sift through all the different repos for just the one thing that you needed. It was also available externally for whatever crazy reason in case a comet hit our data center and our internal GitHub enterprise instance went away. This was posted on the public github.com. So a lot of these things you'll notice are kind of aimed at mean time to recovery. For example, doing runbooks, it means that the clear steps that you have, the resolution will be much faster. As I mentioned previously as well, mean time to recovery, you can improve on mean time between failures. You could also focus on, but you can always do it later. It doesn't have to happen in sync with each other, strictly. So all of this continued for a while, and we slowly began to hit our stride while continuously making adjustments as we discovered different parts of our process that just didn't really work out for us. And so now my story comes up to speed with the present. And you might be thinking, you've done all these things. What's left to fix? Well, like any real problem, person or code-wise, there really is no actual end to anything that you can, to what you can do to improve on things. Please keep in mind, though, the things that I'm talking about now obviously are still in flux because we're doing them right now. And none of this is right or wrong. It's just what we're trying out because obviously we've tried many different things in the past. Now it's trying to experiment with some other things to see what works best for us. So take everything from here on out with a grain of salt. So one of the biggest things that we did recently was to combine the two schedules. So instead of having a Rails on-call team and a Java on-call team, now we just have the one. This might sound crazy, and maybe it is, but we did this knowing that it meant that people would end up being on-call less often. It might be a shitty week for you, but at least that shitty week will only happen every 9 to 18 weeks, depending on how many people are on your team. So the rough idea was that you'd be on call for 1 week and then rotate through everyone else on the team, comes back to your turn, but it'll be quite a while before that actually happens again. And this idea actually came out of the fact that we had combined our previously separate Rails and Java services teams into a single services team. This was based on the expectation that everyone should just be able to develop and maintain all our services behind Yammer, regardless of their primary programming language, which I think is a fair point. And since the team was unified, it would make sense that the schedule is too. Learning from mistakes and problems is good practice for any aspect of life, so we have applied it here as well. On top of the incident reports, we started doing postmortems and retrospectives for every incident that occurred in production. And we made sure that they happened almost immediately after the incident, so it was still fresh in our minds. We also made sure to focus on just a few key questions. The what was kind of the timeline, what happened in what order. This helped us break down and dive into what the actual root cause was, which obviously we would hope to gain from this from the retrospective at the end. The where, which geographical area was also important, not just the fact that we had a London office and a Pacific US offices, but also, is it possible that only certain customers in certain areas of the world were affected? For example, maybe there was something that happened only to Australian customers. That's also important to figure out so that you can dive into what's actually going on behind the scenes. The who, obviously, who had to get involved, and also importantly, did they actually have enough knowledge to resolve this issue? Did we have to go and pull in someone else because this person who was just completely lost on their own? And of course, the why was the root cause. Hopefully, after all of these, we've come across actually what happened. However, this doesn't always happen, unfortunately, just because with a lot of systems in a distributed world, it kind of becomes really difficult to pinpoint exactly what went wrong. But hopefully it will have at least gained a little bit of a better insight on everything after we've done the retrospective. Most importantly, of course, though, is the how. How can we prevent this from happening in the future? Even if you didn't get to a root cause, it's still important to point out things that you can improve in the process and in your system. So were there things in the runbook that could have been added? Are there any alerts that we could have changed so that we would have been notified sooner so that we could have cut down on that mean time to recovery? Things like that. The most important thing, though, out of all of these retrospectives is that we made sure it is not a blame game. And it's not just because we didn't want to point the finger at any one person, but it's really because in such a massive system, a small change here could mean disaster here, and it's a mistake that anyone can make. So we didn't want to put that pressure on any one person. It's collective ownership of the problems and the efforts to fix them. And of course contributes to the fact that hopefully they will not feel burnt out, because if you blame someone for some terrible thing that happens, they're not going to feel good after the fact. We also made sure to do weekly handovers first thing Monday morning in both the US and the UK. The engineers who were on call the previous week would basically get together with the engineers who were coming on call this week and hand over all the incidents that happened the previous week. Maybe something exciting happened to this service here, so they would keep track of that. And they obviously had to make sure that if there were any ongoing issues still happening, that the person coming on call now would be aware of it. So the continuity here was the main goal of these weekly handovers. We wanted to make sure that even if we're rotating between people, that we still have knowledge passed on from each week to week. We also made note of all of the top alerts that occurred most frequently. We have a nice fancy spreadsheet using the data straight out of PagerDuty, and we basically update this weekly at these meetings, and we also keep track of the steps to resolve all of these issues, and if the runbooks were missing any information, we also make sure to note that in the spreadsheets and make sure to get them fixed as soon as we can. So these weekly handovers I mentioned, they happen in both the US and the UK, but time zones are really hard to deal with. So we decided, instead of having all of the engineers having to get together in some meeting, we would just have one person from the UK office joining the US office for their handover, the tech lead in this case, and they would basically hand over anything that was they would just give a summary of the previous handover that they had done in the UK office, give it to the US office so that they also could be kept aware, and make sure that we didn't drop anything on the floor. But this also saved a lot of time for the actual engineers, because they were probably already tired from their shifts, and nobody wants to do 5 p.m., 7 p.m. meetings, and it's terrible. So aside from the reviews, in London, we've also started a side effort to make sure that the engineers are actually feeling like their time on call is doing more good than not. So surveys were completely optional, but engineers who were coming off call were suggested to fill out surveys, and every single time it was the same question, so they knew what to expect. We asked various things like, how was their mood before they went on call versus after they went on call? Was it good? Did they feel more prepared this time than last time? Did they feel less prepared? Did they feel more exhausted or stressed after the fact? Did they work together well with their primary or secondary, whoever person it was? Did they manage to coordinate their commute times and all that kind of stuff? And obviously, we asked them for an on-the-ground perspective of what problems we might have overlooked from a higher view. And the whole point of this really is making sure that we're improving on these things. Lots of things could happen, and we're trying to keep track of all these different things, but we need to make sure that everyone feels that we're actually doing our part to make the whole process better for everyone. And of course, we want to make sure that the engineers feel heard. Their opinions matter too, and we don't want anyone feeling overwhelmed or feel like they're completely on their own when they're having to deal with all these issues that come up. Burnout. Of course, the biggest problem we have, though, is fixing all the alerts that we keep getting. We had so many of them come up, and in a way it was kind of weird that we had a sort of a wave of alerts that would come up. So at first, of course, we had probably not too many alerts because we didn't even bother making them. Then we started having a lot of alerts because we actually started caring and adding them to our services. Then we started saying, well, that's pretty crazy how many alerts we're getting. We have to actually fix them. So they would drop down a little bit. But then after a while, they would start rising again. And maybe it is that some of the systems were a little less stable than before, but I think that it somehow came a little naturally out of the fact that we were trying to improve on the alerts, because as you're trying to fix things, maybe things become, maybe your alerts become a little too sensitive, so it goes off a lot more frequently, but it comes and goes, so it's something that we just had to keep working at. Of course, the first ones that we had to deal with are the noisy ones. These are the very simple ones. It's probably configured wrong, or a threshold that just needs to be changed, or maybe it's not even a necessary alert, so just delete that shit. Flaky ones are a little bit harder than this. Sometimes they might trigger and then it resolves automatically before the engineer can actually go and take a look at it. Maybe the graphs are spiky and you have no idea why. Or maybe even people are working on projects that are working in these different areas, and they just kind of forgot to tell you that, oh yeah, by the way, we're doing all these things with this. So those ones are a little trickier to look at, but obviously just as important. Lastly, of course, there's the real alerts. It's better at this point to have real alerts because it means that, it's actually something that you can address. Obviously, it's not good that it went off at all, but that's a totally different story. And all of these, honestly, you could handle in some automated fashion as well. We don't have this yet, but we plan to set up something like an initial line of defense where we monitor, and at the first trigger of some of the top alerts that we normally get, we can set up it would fire off a script that tries to do an auto repair on it. And then if that fails, then we can actually alert to a human being who could go and take a look at it, but at least some minimum effort has been done by the system itself before an actual person or cat can actually look at it. And you'll notice that a lot of these efforts that we've been focusing on all kind of been focusing on mean time to recovery. But now that we've progressed a little bit, you'll notice that we've added a little bit of a hint of mean time between failure focus as well. So, all of this probably sounds completely insane, and we're actually probably really far from where we want to be still. But we've come a long way, and at least we've seen enough to know better what path we need to take to actually get to our end goal. Hell, before we didn't even really have an end goal, but now we do. So, what is this? Eventually, we want to get to a point where we only ever get one alert per person per day. So that's maximum of 7 alerts in the entire week. This would help further with the fact that our rotations would mean that people are on call less often, because it means that being on call less often would be even less intimidating as well, because you'll know that at least it won't be so bad when you are actually sacrificing your entire week to have to deal with production. And hopefully, of course, it also means that our system is actually more stable, which is obviously good for both the business, because users are happy to be using a site that's actually available for 100% of the time or close to it. And of course, your engineers are happy because no alerts. However, this also means that as we build more and more microservices, we can actually draw new ownership boundaries. So instead of having a single set of services that everybody has to be on call for, maybe we can kind of define different boundaries again. So similar to how at the very beginning we decided to draw the bounds between by technology, Rails versus Java, maybe we can actually go by business feature instead. So if, for example, one of the areas that we have would be messaging, so maybe a team could be in charge of all the messaging related services. They would gain a lot more knowledge in this area specifically. It means that they can respond to incidents a lot faster. They don't have to necessarily pull anybody else in, because hopefully they're kind of the experts in this area. And of course, even if we put them on call 24/7 for these specific services, going back to the fact that we aim to have only 1 alert per person per day at most, it's actually not too terrible if you think about it. The actual chances that you'll be woken up in the middle of the night, for example, are much lower overall. And so basically now, up until now, again, we've been focusing a lot of our efforts to cut down on our mean time to recovery. Now, for us, we think it's time to push up the slider for our mean time between failures. So these goals, you'll notice, actually reflect that. And of course, hopefully someday we'll get to a point where the world is just a box full of kittens and everybody's happy. But why? Why are we going through all of this trouble? Why are we putting all this stress on all of our people? Isn't on-call just for ops? No. Okay, I'm done. I'm just kidding. It's not just one's team responsibility. It's the entire organization's. It's the entire organization's responsibility as a whole to move towards being proactive rather than reactive. If you look up on Wikipedia, and I didn't put the quote here because my professors would have killed me for quoting Wikipedia, so I'll just describe what the definition is for what DevOps means, according to Wiki. DevOps is a culture, movement, or practice that emphasizes the collaboration and communication of both software developers and other IT professionals while automating the process of software delivery and infrastructure changes. It aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. For me, what this basically boils down to is that as engineers, we all feel this responsibility for the code that we ship. We share this with every single one of our colleagues. It's not something that only one team really should feel about their code. When you ship code, it's yours. You should be responsible for it. We also take pride in the code that we write and in knowing that when we deliver value to our customers and therefore to our business, we also deliver quality. If we want to achieve all of this, however, unfortunately, we sometimes need to go through a little bit of pain. After all, no pain, no gain. None of this is easy though, and that is partially why we've taken such a long and convoluted path to get to this place, where we have some form of process that works for us now, but obviously we're still going to keep working on it because, well, nothing is perfect. And we all need some sort of direction. We all need to be herded. Thank you very much for taking time to listen to my story. Again, thank you as well for doing the Friday hug with me. That was very good. If you'd like my help with improving your team's on-call story, no matter what stage you're at, please feel free to tweet at me. That's my handle on most social media. Or if you have any other opportunities on your team as well, I'm open to hearing about them. Thank you, and let's go to lunch.